Today's video is going to be on the three circuits of the Magneto. With the aid of virtual Magneto, I'll be able to build the three separate circuits and explain to you how they work. We're going to start the video with the housing. This housing is probably familiar to you. It looks a lot like the 4300 series Magnetos we have here on just about all the planes. With this particular setup, the iron core is at the top of the Magneto and our rotating magnet is at the bottom. Now for our Magneto to work, we have to be able to get the magnetic field or flux lines to be able to get from the magnet up to the iron core. Well, the flux lines cannot flow through the aluminum housing. So we put in what is known as shoe extensions. These are ferrous metals, probably iron, maybe steel, and they're inserted into the housing. They are pathways to get the flux lines from the magnet up the sides of the Magneto housing into the iron core. So our first part of the magnetic circuit is our shoe extensions. Then we put in a rotating magnet. These particular magnetos that we're going to be discussing use a simple two-pole magnet, north and south. Now the magnet puts out flux lines, and the flux lines will always flow north to south. Now we have our flux lines, we got the magnet, and we got the shoe extensions. Now the final part we need for the circuit is the soft iron core that goes across the top. Once that is inserted into the Magneto and we rotate the magnet, we are allowed now to have the flux lines go up the one side, across the core, down the other to the magnet. As the magnet rotates and the north and south get even with the two pole shoes, we're at full register. That's the maximum flux lines we can have flowing through the iron core. As the magnet turns 90 degrees, we're at neutral. That is when we are at the lowest flux lines. So basically we have flux lines getting strong and weak. Then they go the other way because it's alternating. They get strong and weak. And that's pretty much what the magnetic circuit does. It just sends an alternating series of flux lines through the iron core. Now we're going to discuss the primary circuit. The primary circuit consists of some windings. We got to have a primary windings. Now we need electricity. As you were taught in your general, we need three things for electricity. Because of the magnetic circuit, we already have our magnetic field. We got our flux lines. Because we have our primary windings, we have our coil. Now the last thing we need is movement. Because our magnet is rotating, our flux lines are moving, and they're alternating back and forth, going from one side to the other. As this happens, we produce electricity through the primary windings. This electricity, because both ends of the winding are hooked to the housing, allows the electricity to flow out one end, through the housing to the other end, back through the core, and it just keeps going around in circles. As we all know, as electricity flows through a wire, it creates a magnetic field around the wire. So now we have flux lines around our core, and we have the flux lines produced by the rotating magnet. The flux lines around the core, they expand as the magnet gets to full register, and it contracts when it gets to neutral. That is very important because we got to be able to collapse that magnetic field when we need it. There are certain times through this system we'll get into when we get to the secondary system that we have to collapse that field as quick as possible. So to help us along with that, to help us stop the flow and start the flow and stop the flow, we now add a set of points, breaker points, to our primary system. So now we have the windings and now we have a points. We're going to have a little cam somewhere in the Magneto. This one happens to be on the end of the magnet, and it opens our points. When the points open, the electric flow stops. When the flow stops, the flux lines around the windings collapse. This has nothing to do with the flux lines being produced by the magnetic circuit. It's only the ones in our primary circuit. Now the problem with our breaker points is as they open up, electricity will jump across the points and arc. Well, by arcing, we still have flow. If we still have flow, we still have the current, the flux lines. We need, and when the points open quick enough, the flux line, the circuit will stop and the flux lines will finally collapse. But that's not as quick as we need it. We need it to be almost instantaneous. So now what we do is we add the third part to our primary circuit, the condenser or capacitor, whichever you want to call it. The capacitor is set up to the points, so as the points break, the electricity is able to flow and charge up our capacitor. Because the electricity just enters the capacitor and it doesn't go to ground, our magnetic field is now able to collapse almost instantly. We've stopped our electric flow, our magnetic field around the primary windings collapse. Boom, it's done, it's gone. Until the points close again, the electricity flows, the magnetic flux lines come back. So, as we discussed in the magnetic circuit, we have shoe extensions, we have the iron core, and we have the magnet. In our primary system, we have the primary windings, which is a thick copper wire, usually somewhere around 200 wraps around the soft iron core. Then we have our breaker points to help stop the flow of electricity. And we have the condenser or capacitor to help stop our points from arcing, and it shuts the field down as quick as possible. Now we move to the secondary system. This is pretty much the last circuit of the Magneto. So as we were saying earlier, when our electricity flows through the primary windings and it builds a flux line with a magnetic field, it encompasses the secondary windings. So now we have electricity flowing through the primary windings. We have the flux lines from the primary windings covering the secondary windings. When the points open and those flux lines collapse, through induction, the electricity jumps from the primary windings to the secondary. The secondary windings are somewhere around 2,000 wraps of fine copper wire. So that basically takes our electricity up to about 20 to 30,000 volts. Once the field is collapsed and the electricity's jumped to our secondary windings, as you see in the picture, it has a little tab on it. We must think of our coil inside of our magnetos as two things. They're primary windings and secondary windings, but they're also a step-up transformer. They increase the voltage. We cannot make a whole lot of voltage in our primary circuit, so we have the extra windings in the secondary circuit to build up the voltage. Now, as the voltage comes out of that little metal tab, our high voltage tab, it goes through the rotor. The rotor has a little brush at the end, at the bottom of it, where the electricity will flow up, and you got the little metal rod on top, copper rod, and that actually points to each individual spark plug lead. On top of that, we put the distributor. Inside that black distributor, you have little metal rods that stick down inside. As that little pointer passes each one of those little rods, it sends electricity through those, it jumps the gap, it goes through the distributor cap. Then the next step would be the spark plug leads. Once the juice jumps to the distributor cap, it goes out the spark plug lead into the spark plug and jumps the gap. Now the main things we need to remember is we collapse the field when the points open, which is known as our E-gap. We will be setting them in the class. That is our internal timing, and then we do an external timing. So now our series circuits, magnetic circuit is the magnet, shoe extensions, soft iron core. They produce a magnetic field through the iron core. Then we have our primary circuit. That is the primary windings, the thick copper wire, our breaker points to collapse the field, and the condenser capacitor to make sure it's collapsed as fast as possible. Then we have our secondary windings. That's where the electricity, when the field collapses, jumps to. It also steps it up in voltage. The voltage, there's no place for it to go in the secondary winding, so it has to go out that little metal tab to our rotor button. It goes up through the brushes on the bottom, through the little arm. That arm points to the inside of the distributor block to each one of our spark plug leads. As it points to one and the points break inside our primary circuit, the field collapses, it sends a spark out to that plug. The points will close, we'll build back up more electricity or windings or flux lines. When it rotates to the next spark plug lead, the points will open again, the field will collapse, it'll discharge the electricity, it'll go out to the next plug. The points will then again close. We'll start building up our electric current, our flux lines, and so forth. We point to the next plug, the points open, and the plug juice goes out. And it just keeps doing that over and over again until we shut the engine off.